So on the first part, we're supposed to be matching the following to what their logical equivalent is. So let's go ahead and start with number 1. What's the opposite of a negation P? That should just be regular P, so choice E is the best choice. On number 2, I have a conditional here. What could we do with a conditional just by itself? We could negate some part of it, right? So if all I have is just the conditional by itself, is that denying the antecedent or is that denying the consequent? That's just denying the consequent. So which one of these is denying the consequent? Choice F is denying the consequent. That means choice F is our best answer here. On number 3, I'm doing the opposite of a conjunction. The opposite of a conjunction is a disjunction. What's the name of that law? That's De Morgan's law. So the opposite of a conjunction should be a disjunction. That would be choice C. On number 4, what's the opposite of a disjunction? That's a conjunction. Whose law is that again? That's De Morgan's law. So that would be choice D. And then I have the opposite of a conditional. Remember that a conditional is normally true 3 out of 4 times. The opposite of that, the negation of that, would be true 1 out of 4 times. So I'm looking for something that's a conjunction that denies the... Denying the... Is it denying the antecedent or denying the consequent?
Is it number 2 supposed to be A?
Yeah, it is, actually. That's a mistake I made. Number 2 really should be A. Number 5 should be F. And then we've got this Q conditional P. What allows me to switch and exchange and negate the antecedent and consequent? That would be choice B. What's that called when I switch and exchange when I negate and exchange the antecedent and consequent? That's contrapositive. Okay. All right, so part 2, it says, show that the following 2 statements are not logically equivalent, using a truth table. So first thing I have to do is I have to figure out what Q conditional P is. So tell me about Q conditional P. Okay, yes?
I'm trying to figure out which one is telling you, like you're doing something, but you don't get to do what you're promising.
Right, this is where, I need to check to see where my mom is lying to me. So what's my antecedent?
The Q.
Q is my antecedent. This is my antecedent. What's my consequent?
P.
P. So I'm looking for a true here and a false here. Which row has a true in the second column and a false in the first column?
The third row.
The third row does. Okay? So that's the only place that I get has to be true. And so this is the left side. So now I need to do the right side. The right side involves negation of stuff. So what should I put down first?
Negation P.
Negation P. Tell me about negation P.
It's 2 false and 2 true.
Okay, it's supposed to be the opposite of true, true, false, false. So false, false, true, true.
And then you have to do negated Q.
I need to do negated Q now. So I've got negation Q.
False, true, false, true.
False, true, false, true.
And then you have to put negated P, conditional negated Q.
Exactly. So which is my antecedent? Which column?
Negated P.
Negated P. This fourth column is my antecedent. What's my consequent? Yes.
Well, it would be the negated Q.
Negated Q, this fifth one. Mm-hmm. So where is my mom lying to me? Where is the antecedent true and the consequent false? Okay. Again, on the third row, my antecedent is true and my consequent is false. That's the only time a conditional is going to be false. That means everything else has to be true. So this is what I've got. Are they logically equivalent?
Yes.
Yes. Okay. Any questions on the quiz? All right, go ahead and take out a sheet of paper for notes. So I only have one definition for y'all as well today, and that definition is biconditional. So a biconditional is a statement that is only true if two statements have equal truth values. A biconditional is a statement that is only true if two statements have equal truth values. So let's talk about what that would look like if I was going to do this in a truth table. By the way, the symbol for a biconditional is an arrow that's pointing both directions. Now, in other words, not just pointing to the right like a conditional, but it's pointing in both directions. That's a biconditional. If you think of a bicycle that has conditional is a statement that is only true if two statements have equal truth values. So on which rows are P and Q equal?
The first and last.
The first and last. So those are the only places I get to put true. That means everything else has got to be false. So this is what the truth table for a biconditional looks like. And the key word here for a biconditional is if and only if. So if I wanted to write this as a sentence, I would say something like, it is raining if and only if Mr. Potter's shirt is pink. Because yesterday I was wearing a pink shirt. And of course yesterday it was raining. Now, if and only if. I've heard these words before. Where have I heard if before? We heard if when we were talking about conditionals. Where have we heard and before? That's a conjunction, right? Where have we heard only if before? That's also conditionals. That was one of the 5 ways we had to write conditionals. Remember that we had Q if P and we had P only if Q. So that's really the 2 conditionals that we have. And we actually have something that's rather interesting here. A biconditional is logically equivalent to the conjunction of 2 conditionals, P conditional Q and Q conditional P. A biconditional is 2 conditionals put together. So I want to prove this using a truth table. Remember, what does it mean for 2 statements to be logically equivalent?
That they have the same truth value.
Okay, it's 2 statements are logically equivalent if they have identical truth outcomes. They have to have the same, not just one truth value, all the truth values have to be the same. Now we just did P biconditional Q. So we've already done the left side, which means now I want to do the right side. So again, I'm going to start with P and Q. P is going to be what? And Q? So tell me about P conditional Q. Yes, ma'am. Huh? Row 2 is the only place where I'm going to be false. That means everything else? True. Now, if I'm doing Q conditional P, because that's my other parentheses, tell me about Q conditional P. How is that different? How is it different?
That they switched.
They switched, right? That means this is now my antecedent and this is my consequent, which means I'm looking for true in the second column and false in the first column. So which row does that happen in? Row 3 is where that happens. That's where I have a true in the second column and a false in the first column. So that means I've got a false in row 3. And if I'm doing P conditional Q and Q conditional P, I'm doing a conjunction. A conjunction is a statement that is only true if Two given statements are both true. Where are they both true?
The last row and the first row.
Okay, the last row they're both true. The first row they're both true. In the second row I had a false because it was a conditional. That's that true, false, true, true that we're familiar with. In the third row I had a false because the antecedent and the consequent had switched. So I end up with true, false, false, true. And what do you notice about this logical outcome and this?
They both match.
They're identical, aren't they?
Because they are both biconditional.
So biconditional is logically equivalent to that expression. So a biconditional is logically equivalent to two conditionals. And that's why we use if and only if. So that's the only definition we have for today. But there's something else that I'd like to talk about today. Y'all may remember that we kind of skipped problem 9. And we skipped number 9 because we hadn't really talked about the stuff yet, but we talked about it yesterday, actually. So there's a couple of laws that I want to remind you of, and one of them is De Morgan's law. So when we talked about De Morgan's law, we said that there are actually two forms of this law. One of the forms says the opposite of a conjunction is a disjunction. So what would negation parentheses P conjunction Q be logically equivalent to? Negation P, disjunction, negation Q. Remember, the opposite of a conjunction is a disjunction. Everything gets negated. P gets negated, Q gets negated. But whenever I see a conjunction, what word does that mean? So when I'm talking about this, I would have a sentence like, it is raining and Mr. Potter's shirt is pink. That's what a conjunction would look like. But if I want to take the negation of that whole sentence, De Morgan's law says I'm supposed to change an and to a or. So it's no longer an and sentence. It's now a disjunction. It's now an or sentence. And I'm supposed to negate both of my statements. So what's the negation of it is raining? It is not raining. And what's the negation of Mr. Potter's shirt is pink? Mr. Potter's shirt is not pink. Now, yesterday we briefly talked about compound sentences. Compound sentences are where you put sentences together with and or with or. And on problem 9, I asked you to find the negation of compound statements. In other words, the opposite of an and sentence, the opposite of an or sentence. And if I want the opposite of an and sentence, I'm going to end up with what type of sentence?
An or.
I'm going to end up with an or sentence. Why? Whose law says so? De Morgan's law says so. De Morgan's law says that the opposite of a conjunction is a disjunction. The opposite of an and statement is a or statement. Okay? That's why we have De Morgan's law. Because if someone says, it is raining and Mr. Potter's shirt is pink, and I want to call them a liar, do both of those things have to be wrong? Only one of those things has to be wrong. Either it is not raining, or Mr. Potter's shirt is not pink. Remember, a conjunction is a statement that is only true if both given statements are true. If I want to mess it up, how many statements do I have to mess up?
One.
Only one. I either have to mess up the first statement or I have to mess up the second statement. If I have a conjunction and I want the negation of it, I want to say it's the opposite of the first statement or the opposite of the second statement. Similarly, if I was to say something like, the room is dark, or hot dogs are for lunch, and I want the negation of this statement, the room is dark or hot dogs are for lunch, what does De Morgan say about the negation of an or statement? It becomes an and statement.
So it would mean the room is not dark and hot dogs are not for lunch.
The room is not dark and
Hot dogs are not for lunch.
hot dogs are not for lunch. What De Morgan says is that if I want the opposite of a conjunction, I'm going to get a disjunction. If I want the opposite of a disjunction, I'm going to get a conjunction. So I've got to make it an and sentence. And if I'm going to do the negation of a disjunction, I have to negate both of those statements. So I have to negate the first statement, the room is not dark. I have to negate the second statement, hot dogs are not for lunch. That's what De Morgan's law says. And there was one more statement that we had when I wanted to negate something. We talked about negating a conjunction, we get a disjunction. We talked about negating a disjunction, we got a conjunction. If I want to negate a conditional, do y'all remember what we get? We get a conjunction out of it. Is that denying the antecedent or is that denying the consequent? That's denying the consequent. Because here's the thing. I want to deny a conditional. I want to know when a conditional is negated. In other words, I want to know when my mom is lying to me. In other words, I want to know where the first statement is true and the second statement is false. That's why it's denying the consequent. So the opposite of a conditional statement is going to be a conjunction. So if my mom says, if you clean your room, then you can go to the mall. My goodness, we've said that sentence a lot, haven't we? If you clean your room, then you can go to the mall. And I want the opposite of that sentence. When did my mom lie to me?
If you clean the room, then you will not go to the mall.
Well, when my mom lies to me, if I clean my room and I don't go to the mall. So the negation of a conditional statement should be a conjunction. I clean my room and you didn't go to the mall. That's when my mom is lying to me. So we learned all these rules. We learned De Morgan's law, we learned denying the antecedent, we learned denying the consequent. The reason we learned them is because of English. The reason we learn these is because we want to be able to take a sentence and find out what sentence has the opposite truth value. What sentence is a negation? That's what De Morgan's law is used for. That's what denying the consequent is used for. Does that make sense?
Yes.
Okay. So on question 9, on your homework, they ask us to do the negation of the conjunction, or the negation of the disjunction, or the negation of the conditional. They're asking us to use De Morgan's law and denying the consequent to answer these, to write a sentence in response. So that's what we're really looking at. Now there's one other rule that we really haven't talked about, and that's denying the antecedent. We haven't really talked about denying the antecedent, so let's write that out logically. Symbolically, we said denying the antecedent said that we could take a conditional, P conditional Q, which is true 3 out of 4 times. And that's going to be logically equivalent to another statement that's true 3 out of 4 times. Because a disjunction is only false if two given statements are both false. So 3 out of 4 times it's going to be true. Only 1 out of 4 times is it going to be false. That's how I know it's going to be a disjunction. And it's going to be a disjunction, so I need to figure out when they're both false, and they're both false on the second row. The second row is where the first statement is true and the second statement is false. The second row is where my mom is lying to me. I need to change where my mom is lying to me into a statement where both parts are false. And that's why I negate the first one.
So that's why instead of it being like, if I clean my room, I can go tomorrow, instead of being, if I don't clean my room, I cannot go tomorrow.
Well, it's not going to be an if, it's going to be an or. We're making it a disjunction. So it's, I didn't clean my room, or I went to the mall. Okay? So if my friends see me at the mall, what can they assume? I must have cleaned my room, right?
Yeah.
If they don't see me at the mall,
You didn't clean your room.
I must not have cleaned my room. One of those things has to be true. Either I didn't clean my room, or I'm at the mall. Take the statement, if you clean your room, then you can go to the mall. If I take that sentence and you know what? You see me at the mall? I must have cleaned my room. If you don't see me at the mall, I must not have cleaned my room. So in other words, if you clean your room, then you can go to the mall, means the same. This is logically equivalent to you didn't clean your room, or you can go to the mall. Because the only time that statement's going to be false is if both statements are false. The only time that statement's going to be false is if I cleaned my room, which is the opposite of the first part, and I didn't go to the mall, which is the opposite of the second part. And of course, the opposite of a disjunction is a conjunction. So it all makes sense. It's kind of this big circle. So, tonight's homework, you're going to read pages 12 through 14. You're going to work on that problem 9 now that we finally have the background for it. And you're going to work on problems 19 through 24, which is more practice on truth tables. Why are we learning truth tables? Why are we learning truth tables?
So I can help us find the answers for conjunctions and to learn all possible options for the things that we.
Exactly. The thing is, we've been proving that statements are logically equivalent. In other words, statements have the same meaning. I have to do truth tables because a truth table is a table that shows all possible truth outcomes. If I'm supposed to show that they have identical truth outcomes, I need a truth table. So that's why. Are there any questions? All right, if there are no questions, then I release you to your PA. Have a wonderful day.